Hello friends, today we will see chapter 2 Polynomials. Introduction. First, see polynomial. Here polynomial means what? An algebraic expression in form of, that form is written standard form a0 x raised to n plus a1 x raised to n minus 1 plus a2 x raised to n minus 2 plus dash dash a n minus 1 x plus an. Then see what is the terms here where n is. Here n is given raised to x raised to n, that n is a whole number. So whole number means what? Means any 0 to 0, 1, 2, 3, 4. In first lesson, we studied whole number. Whole number means what? In introduction, you can see the introduction of that. 0, 1, 2, 3, 4, dash, dash, mean infinity, till infinity. So, there is a no end. So, whole number. N means it can be 0, 1, 2, 3, 4, 5, dash, dash. And A0, A1, A2, dash, dash, till A n are real numbers. Then real number also we know that there is a rational and irrational number means real numbers, and constant term x, and constant term not x but there is a an are the real numbers and constant term, and x is called real variables. X is called variable, and constant term means what? The numbers are given. This polynomial is usually denoted by p of x, and other things f of x also is there some, but mostly we are using p of x. Now degree of polynomials. Degree means what? Here see x raised to n, index means this index is there, then we have to see the degree or index of that polynomial. Highest degree raised to n is given means we have to check the n. That n is called degree, but which n? Here also n is given, but highest degree. Polynomials of a degree 1, 2, 3 are called linear, quadratic and cubic polynomials respectively. Means what? Polynomials degree, if here degree is 1, that one is the highest degree, then that polynomials called linear polynomials. If degree is 2, here see degree is 2, then it is quadratic polynomials, and if degree is 3, then it is called cubic polynomials. Now first here see again linear polynomial. Already we seen if degree is 1, a polynomial of the form of ax plus b. Now see here x raised to what? Nothing is there, that means it is a n. Okay, then that n is the highest degree, means it is a 1. See here we saw already, if degree is 1 then it's linear. So here degree is 1, so it is linear polynomial, and it is a highest degree, its degree is 1. Now second one is quadratic polynomial. A polynomial of a form of ax square plus bx plus c. A not equal to 0. A not equal to 0. If a equal to 0, then this term, first term will become a 0. Then it will not become a quadratic polynomials. Here also see a not equal to 0. If a is 0, means a is 0, this first term will become a 0, then only b will remain. Then it is not possible. We can't see linear polynomial. So it is given a not equal to 0. This condition is there. If means it will start from 1. Then see ax square plus bx plus c. Here degree is highest degree is 2. If 2 is there, it is a quadratic. Already we saw here if degree is 2, then it's called quadratic equation. Now here ax, this is the standard form, ax square plus bx plus c. Highest degree is 2, so it is a quadratic polynomials. Then third one, cubic polynomial. A polynomial of the form of ax cube plus bx square plus cx plus d. A not equal to 0. Again same, if a equal to 0, first term will become 0, so we can't see cubic polynomial. So a not equal to 0 is called cubic polynomial, and degree is 3. Here highest index is 3, so it's called its degree is 3. Now next topic is there zeros of polynomials. What is the meaning of the zeros of polynomials? A real number k is said to be a zero of a polynomials p of x. We already saw polynomials is denoted by p of x. This p of x means here see a real number k is said to be zero of a polynomials p of x if p of k equal to 0. Then we can say the zeros of a polynomials. Now here see geometrically we have to see geometrically the zeros of the polynomials. This geometrically you can use in exercise 2.1. There is a graph is given and with the help of this concept you can solve the exercise 2.1. Here see again geometrically the zeros of a polynomial p of x are the x coordinates of the points where the graph of y equal to p of x intersect the x-axis. If graph is intersect the x-axis, you know that in graph x and y coordinates are there, axis are there, not coordinates, but in graph x-axis and y means we have to draw x-axis and y-axis. If y equal to p of x means what? Here polynomial that intersect the x-axis. Now see if linear polynomial has one and only one zero, means only linear polynomial has one and only one zero. Then quadratic polynomial has at most two zeros, means two values you will get. Then cubic polynomials, because degree is 3, here degree is 2, here degree is 1. So here if degree is 1, you will get the value also only 1 0. Quadratic degree is 2, you at most you have the two zeros. If cubic polynomials means what? You know that degree is 3, so zeros also 3 you will get. In general, a polynomial of a degree n has at most n zeros. Degree is n, so at most zeros also n. Then see graphs of a different types of polynomials. This concept you will use in exercise 2.1. Some examples are given, but before that, so you should see this concept, then you are able to solve exercise 2.1. Now linear polynomial. The graph of a linear polynomial p of x equal to axb is a straight line that intersect x-axis at one point only. Is 0 is only 1, so it intersected also one point and that only will get the 0. Then quadratic polynomial. Graph of a quadratic polynomial p of x equal to ax square plus bx plus c is a parabola which opens the upwards if a greater than 0. If this a is greater than 0 and intersect at x-axis at a maximum of a two distinct point. See here parabola. Parabola means this shape is, see here this shape means this parabola shape, and open upwards. This open upwards means see this position of this parabola or this figure. That one is called its parabola and which opens upwards. But when it will this a is greater than 0 and intersect x-axis at a maximum of a two distinct points. Upward like here given, no upward like, so meaning is there upward like means like this position will come. Then second, graph of a quadratic polynomial p of x equal to ax square plus bx plus c is a parabola which opens downward. Parabola means you know that, see parabola figure and here open downwards. Downward parabola means meaning of this parabola which opens downwards like this figure you will get, or on graph this figure you will get if a less than 0 and intersects x-axis at a maximum of a two distinct point. If this downward parabola, when we will get a less than 0, then cubic polynomial. Cubic polynomial, graph of a cubic polynomial p of x equal to ax cube plus bx square plus cx plus d intersect x-axis at a maximum of three distinct points. Then it's intersect at a 3 degrees, means 3 zeros you will get. Now next point is there, if alpha and beta are the zeros of the quadratic polynomials ax square plus bx plus c, then alpha plus beta equal to minus b upon a and alpha beta equal to c upon a. These formulas you will use in exercise 2.2. Now here alpha beta and here minus b, here c, here given that c a is here, means whatever coefficient of this, that means it is a. This coefficient of x square means b and coefficient of x means c and d means this is the constant. So with the a plus alpha plus beta equal to, what is the formula, minus b upon a, means this b upon a but minus sign is there, and alpha beta equal to c upon a. Okay, now next is if alpha beta gamma are the zeros of the cubic polynomials. Alpha beta are the zeros of the cubic polynomials. See, x cube ax cube plus bx square plus cx plus d, then alpha plus beta plus gamma equal to minus b upon a. Now here see b upon a, then alpha beta plus beta gamma plus gamma alpha equal to this c upon a, and alpha beta gamma equal to minus d upon a. These formulas and this concept you can use in exercise 2.2. So next video we will see exercise 2.1. Before that, don't miss out this your introduction